Hello guys, welcome back to the quantity surveying workshop and into another video. In today's video we are going to be measuring the quantities for the roof members, and the roof we are going to be measuring for is a hip roof. Now in this video we are going to be measuring 3 members, and they include the wall plates, the ridge board and the tie beam. Now if you watch the introduction to the measurement of this particular hip roof, you would remember in the calculation for the wall plates, I said that the wall plates are situated at the slanting side of the building. Now for a hip roof, you know that the hip roof is slanting on all 4 sides, so it means that we are going to be having our wall plates around the external gates of our building. So all you need to do is to find the external length of the plan and the external width of the plan. We know that the out-to-out dimension for the length is 12,825, and that of the width is 10,725. So now, having these 2 parameters, we are going to be using it to calculate for our wall plates. Now the length, like I said, is 10,725. The width is 12,825. We are going to be timesing it by 2 because the wall plate will be found on the 2 lengths and on the 2 widths. Meaning, if this is the length, the wall plate will be found here and here. If this is the width, the wall plate will be found here and here. Now when you times it together, the total length of the wall plate will be 21,450, and the total width of the wall plate will be 25,650. Now after doing this, we are going to be measuring for what we call the scarf joints. Now when I say the scarf joints, this is what I mean. Let's use this for example. If the standard length for a wood is for example 3.4 meters or 3.8 meters as used here, it means that for longer lengths we have to use more than 1 standard length of wood. So now, for example, we know that the length of our wall plate is 10,725, and it is more than the standard length of timber, which is 3.8 meters. So we need to know how many joints would be needed to make up 10,725 using 3.8 meter long timber. Now what this scarf joint means is just a way of joining the wood together. Now this is a method of jointing in construction, so this is one method of scarf jointing. So all we need to do now is to determine the number of scarf joints that will be required to span the length of the wall plates. So we know that, okay, let me just put it this way. If this is 10,725, from here to here is 3.8, here to here is 3.8, here to here is 3.8. So you keep doing it 3.8 until you reach 10,725. So now how do we join this 3.8 on the joints? We are going to be doing this technique called the scarf joints. So all you need to do now is to determine how many scarf joints will be needed. Now to do that, you know that we've gotten 21,450 as the total length, that's the 2 lengths. Now after getting 21,450, all you need to do now is to divide it by the standard length of timber, which is 3.8. So doing that, we got 5.64, approximately 6. So it means that we're going to be having approximately 6 scarf joints. So we're going to be having 6 scarf joints that will be joining 3.8 meter wood to give us 21,450. Now after doing that, we are going to be doing for the width. we know that the total width we have is what, 25,650. So 25.65, that's in meters, divided by what, 3.8 meters, will give me what, 6.75, approximately what, 7. So it means that the amount of scarf joints we are going to be having at the total of the width would be what, 7 in number. So when you add them up, it will give you what, 13. Now doing this, you've calculated for what, your wall plate. So now all you need to do now is to what, describe. And as stated in our specification, the wall plate we are going to be using is what, 50 by 100 mm wall plate. So we'll describe 50 by 100 mm hardwood timber wall plate, jointed at the what, 4 corners. Now what I mean by jointed at the 4 corners is this. You know that the wall plate is going to be going round the building. So at the corners here, we are going to be having joints to join the woods together. Now that is what I mean by jointed at the 4 corners. So, and bedded to wall. So we are going to be bedding the wall plate to the wall so that it will be what, stable. Now after doing that, all we need to do now is to what, measure. So now we measure by saying what is the length of one side of the wall plate. We know that the length of one side of the wall plate is what, 10,725. So now we book 10.73. We multiply it by 2 because it is on both sides of the length we're having wall plates. That's why we multiplied it by what, 2. So the next thing we're going to be doing now is for the width. The width is what, 12,825. So we book 12.83 and then we times it by what, 2, because they are on both sides of what, the width. Now after doing that, you go to your squaring column. Now this times this, that's 2 times 10.73 will give me what, 21.46. So this is the total for the two lengths, the length on both sides. Now 2 times what, 12.83 will give me what, 25.66. So this 25.66 is the total width for what, both sides. Now adding them up, it will give me what, 47.12. This 47.12 is the total amount of wood in meters that we are going to be using to what, construct our wall plates. After doing that, all you need to do now is to what, describe the amount of scarf joints you've calculated. We calculated what, 13 in number, so we just book 13 and then we close. Doing this, you've booked for your what, wall plate. The issue with roof is that roof is kind of straightforward to calculate because it is in linear meter. But now the only issue now is understanding how these roofs are constructed so that you can easily understand how you can carry out the measurements. So now after measuring for the wall plates, the next thing we are going to be doing is to know the number of trusses that will be required to construct this roof. And I told you, like in the introduction, that the trusses are located on the along the ridge board of the roof. Now, in order to find the number of trusses that will be used to construct this roof, you need to first determine what is the length of your ridge board. Now, this part of the roof from here to here is your ridge board, and the truss is going to span along that ridge board. Now, in order to do that, what you need to derive or to take in cognizance is the width of your building. And the width of our plan is what, 10,725. So now, if the width of our plan is 10,725, it means that if you look at this section, this is the section from what, AA. If you cut it like this, because this is the hip side, this is what you are going to be what, seeing. Now there is a formula that states that in order to know or to determine the beginning of our ridge board, the beginning of our ridge board, which is here, we have to divide the width by 2. whatever we get is the distance from here towards the beginning of our ridge board. The reason why we're looking for this is so that we can know what is the length of our ridge board. If we can know the length of our ridge board, then we will know the number of trusses that we will have in this building. As you can see, look at this distance. We have what? A and what? B. The width of our plan is what? 10,725. We need to find what is A and what is what? B. Now, if you divide this plan like this, if you divide it horizontally like this, this is what we are going to be having. We're going to be having this. Now, the distance of C is equal to the distance of what? A. The distance of D is equal to the distance of what? A. Therefore, if here F is our ridge board, the distance F is equal to what? The distance E. This is simple arithmetic, simple trigonometry. This is a rectangle. Opposite sides are what? Equal. That means E will be equal to what? F. So if we can find the dimension of E, it means that it is equal to what? Our ridge board, and that is what we are looking for. So now, in order to determine what this ridge board is, let's put our focus on E. Now, we said that the distance of half of our width, which is A, is equal to what? C, and is equal to what? D. Just like the formula I put here. A is equal to B, is equal to C, and is equal to what? D. So now, how do we derive our A? All we need to do is find our width, 10,725. You divide it by what? 2. And it will give me what? 5,362.5, which is equal to what? A. So if A is equal to B, and is equal to C, and is equal to D, how do we now determine our what? Ridge board, which is F. We know that A is equal to B, is equal to C, and is equal to D. And our A is what? 5,362. So if C is 5,362.5 and D is 5,362.5, and we know that the total span of our length is 12,825, how do we find E? All you need to do is add D and C and minus it from the word total span, and that is what we did here. So we said after we found our A, therefore the length, which is what? 12,825, we're going to less what? Half the truss, which is what we did here. Half of 10,725 times what? 2. We are timesing it by 2 because of we are going to have 1 at C. We're going to be having it at what? D. So now, when we times it by 2, we had what? 10,725. Now we left it from this one, and what we had was what? 2,100. So if E is equal to F, it means that E, that's from here to here, is what? 2,100, and then our ridge board, which is F, is what? 2,100. Now we've gotten the length of our what? Ridge board. All we need to do is to what? Divide it by the spacing of our truss in the specification. And if you look at this drawing, they say that our truss, the trusses is at what? 1,200 center to what? Center. So all you need to do now is to take the dimension of your what? Ridge board, which is 2,100. You bring it down and divide it by your what? Spacing, which is 1,200. And what we got was what? 1.75. That's approximately 2. Then what? Plus 1. The number of trusses now will be equal to what? 3. So now, just a quick hint. Since we know that our trusses are made up of what? The rafters, the tie beam, the king post, and the struts, it means that anything we are going to be calculating, for example, the king post, we are going to be timesing it by what? 3, because the king post is only found at what? The trusses. I hope you understand. if we are calculating for the rafter, we have 2 rafters in a what? Truss. So it means that the length of our rafter will times it by what? 2, because there are 2 rafters in a truss, and then we'll times it by what? The number of trusses we have, which is what? 3. Doing this, we've calculated for the number of trusses as what? 3 number. So now the next thing we are going to be doing is to what? Determine the length of our tie beams and the number of our what? Tie beams. Like I said before, the tie beam will span the width of what? Your building. The width of your building is what? 10,725. So it means that your tie beam is going to be the same span as the width of your what? Building. So now we need to know the number of tie beams we have in the plan. Now your tie beam is going to span, or is going to go across the length of the building. So now we know that the length of the building is what? 12,825. All you need to do is to divide the length of the building by the spacing that has been stipulated in our what? Specification. And our specification says that what? Our tie beam is what? 1,200 what? Center to what? Center. So all you need to do now is this: you get your length, which is 12,825, and then divide it by your spacing, which in this case is what? 1,200. So now that is what I did here. Length is equal to what? 12,825. You divide it by the spacing, 1,200, and it will give me what? 10.68, which is approximately what? 11 number. So we're going to be having 11 tie beams across the span of 12,825. We know that the length of our tie beam is what? 10,725. So now all you need to do now is to what? Describe. The specification states that our tie beam, the dimension of our tie beam is what? 50 by what? 150 mm. So we will now state 50 by 150 mm hardwood timber tie beam, fastened to what? Wall plate. I explained this in the introduction, with all necessary what? Scarf joints. Now, just to save time, we didn't calculate the scarf joints because that should be straightforward. Let me repeat myself again. The standard length of the timber we are using is 3.8 meters, and the length of one tie beam is what? 10,725, which is more than the standard length. So in order to get the amount of joints that you are going to be linking this timber together to get 10,725, all you need to do now is to do what? 10,725 divided by what? 3.8. Whatever you have is the amount of scarf joints you would have in what? One tie beam. Then you times it by the number of tie beams you have, which is what? 11. After describing this, all you need to do now is to what? Put in your measurements. Now we know that the length of our tie beam is what? 10,725. Convert it in meters, which is what? 10.73. Then we times it by the number of tie beams we have, which is what? 11, that we've already calculated. Now when you times it together, it will give me what? 118.03. Now this 118.03 is the total length of wood we are going to be needing to make 11 tie beams of a span of 10,725. I hope you understand the logic. Now the next thing we are going to be booking for is our what? Ridge board. There is no need for waste calculation here because we have already calculated this when we were determining the number of trusses, and we calculated previously that the length of our ridge board, which is F, is what? 2,100. So all you need to do now is to what? Book. The dimension of our ridge board in the specification is what? 50 by what? 150 mm. So we'll describe 50 by 150 mm hardwood timber ridge board, and then you close. What is the dimension? 2.10. Now this 2.10, it is within the length of what? a standard timber, is within the standard length of timber, so there's no need for what? Scarf joints. Scarf joints are only used to link two timbers together to form a particular length. So we've come to the end of today's video. I hope you derived adequate knowledge from it. Please, if you did, don't forget to like, share and subscribe to this channel. It helps the channel grow. Thank you, and we'll see you in the next video.